My name is Douglas Bean. Welcome to the second video of an exploration of graph databases with Neo4j. In this video, I'm going to demonstrate data modeling of a simple social network in a graph database with Neo4j, and I'm going to compare it to how such a network might be implemented in a SQL database. A social network is an example of a real-world graph. I'll begin with the SQL implementation. We have two tables, one to store person entities and the other one a join table to store relationships between them. We also have some SQL code here to create some person entities and some relationships between them. We see right away that we have to deal with foreign keys, which is accidental complexity added to our data model. Complexity which is necessary just to make it all work. Even though we have object relational mappers, we still have to deal with foreign keys in the SQL code that we write. And here are some queries or questions to ask of our social network. The first query, who are Bob's friends, performs well enough because it is constrained by the Bob qualifier. The second reciprocal question, who in the network considers Bob to be a friend, is problematic from a performance point of view because every record in the person-friend join table has to be considered. Yet these reciprocal types of questions are the basis of product recommendation engines, such as which customers bought a certain product as opposed to which products did a customer buy. We can add indexes, but they only take us so far, and they are not without cost. Another thing to note about these queries is that they are recursive. Recursion is used to build hierarchies in SQL. They are computationally and syntactically complex, and they are not intuitive to read. Now this third query goes one level deeper into our social network, asking who are the friends of Alice's friends. It is even more complex computationally and syntactically, and even less intuitive to read. Now let's model the same social network in a graph database with Neo4j. Here is some cipher code to create some persons, entities, and some relationships between them. We'll copy them into the Neo4j browser and execute it. And here is our social network. Now let's create an index on our person entity. The index is used to find the data nodes that are the starting points or the anchor points of our queries, or in other words, the starting points of our graph traversals. Now let's ask some questions of our social network. We'll get the friends of Bob. And we get Zach and Alice. Now let's ask the reciprocal question, who in the network considers Bob to be a friend? The reciprocal question is no more costly computationally than the first one, and it is just as concise and as intuitive to read. Now let's go one level deeper into the social network. This cipher query will get the friends of Alice's friends. And we get Zach. Now this query is not without some complexity. It took me a little tinkering to get it to work, but it is far more intuitive to read and less costly to execute than its SQL counterpart. Now this query, this cipher query, will get the same result using pattern matching. There we go. Now let's add another relationship between two data nodes in our graph. Bob and Alice hit it off and they decide to get married, so we add a married relationship between them. Now let's query by that relationship. In Neo4j, there can be multiple relationships between data nodes. Now, this ability to easily add and remove relationships between data nodes reveals something that is important. In Neo4j, data nodes and the relationships that connect them are loosely coupled, giving the data model flexibility, making it easy to change. In a SQL database, tables and the relationships between them are tightly coupled, making the data model rigid, inflexible, and difficult to change. It seems that a native graph database is better suited to adapt to changing business requirements compared to a SQL database. Thank you for watching my second video of this series. In the next third video, I'm going to model a many-to-many relationship in a Neo4j graph database, and I'm going to compare it to how a one-to-many ad hoc relationship might be implemented in an aggregate data store, that is, a document database.